And another question is slightly different from what we have been doing. And the question says 3.52 grams of carbon dioxide and 1.40 grams of water are produced when a mass of a hydrocarbon is completely burned in oxygen. Determine the empirical formula of the hydrocarbon. So in terms of the rates of combustion or the way compounds burn in oxygen to produce particular compounds or products, we are supposed first to understand the difference between an empirical formula and a molecular formula. For example, if I talk about CH2, this is an empirical formula. It is an empirical formula because if you look at it, it is actually a formula in which atoms are in their simplest whole number ratio. You see, for example, I have carbon and hydrogen. The simplest whole number ratio in which these atoms exist in this compound is 1 to 2. One carbon atom and two hydrogen atoms. And another example can be this. You cannot talk about this one being an empirical formula because the atoms are not existing in their simplest whole number ratio. Why? Because I can further divide to end up having CH3. So C2H6 cannot be an empirical formula. An empirical formula is a formula that shows atoms which are in their simplest whole number ratio in that structure or compound. So a formula showing the atoms in their simplest whole number ratio. So this is an empirical formula. Or someone can talk about C3H7. You cannot further divide these two. There's no common divisor between 3 and 7. So this seems to be our simplest whole number ratio in which these atoms are existing. That can be what you call an empirical formula. And a molecular formula is a formula that actually gives us the actual number of each kind of atoms. For example, I can say C4H10. This is a molecular formula. It shows the actual number of each kind of atoms in the compound. For example, we have 4 carbon atoms and 10 hydrogen atoms. A molecular formula. A formula that shows the actual number of each kind of atoms in the compound. So we have been told that we have a hydrocarbon. And of course, a hydrocarbon can either be an alkane, alkenes, or even an alkyne. And organic chemistry 1 and organic chemistry 2, different types of hydrocarbons have been discussed. We have alkanes, alkenes, and alkynes in organic chemistry 1. Further, we may not just limit ourselves to hydrocarbons, compounds containing carbon and hydrogen. We have also even introduced these other compounds that may also contain other atoms. We've talked about alkanols or alcohols that contain carbon, hydrogen, and oxygen. The general formula CnH2n plus 1 OH. We have what we call alkanoic acids or alcoholic acids or carboxylic acids that have a general formula of CnH2n plus 1 COOH. We have polymers, we have detergents. So they are just examples of compounds containing carbon and hydrogen, but further containing also other elements. So you've been told that there is a hydrocarbon here, of course, containing carbon and hydrogen. This hydrocarbon has undergone combustion. That means it has been burned in oxygen. And that translates into us having this. The hydrocarbon is CXHY. Okay? It is undergoing combustion or burning in oxygen to give us, of course, oxygen is the active part of air that supports combustion, to give us carbon dioxide and water. We've been told that 3.52 grams of carbon dioxide has been produced and 1.40 grams of oxygen of water has actually been able to get produced. So if oxygen gets used here and burns or allows this compound to burn to produce this carbon dioxide and this water, then this can be our two very important products with those masses to get considered. So the question asks for the empirical formula of the hydrocarbon. Very, very, very easy for us to actually work out this question. Let me just try to get enough space for us to actually proceed. So I'll just come here and say element, or we can even talk about compound. Okay, molar mass, and we have moles. So the compound is carbon dioxide and water. we want to see the ratio of carbon dioxide to water in that compound. And you can have first mass, then you can have molar mass. So our mass is 3.52 grams, and this is 1.40. So the molar mass of carbon dioxide is 44, and the molar mass of water is 18. Yeah, I think you know where I'm getting this. So we have carbon dioxide, I know this is 12 for carbon and 16 for oxygen, then times 2 because there are 2 atoms of oxygen. That gives us 44. Then for water, you need to talk about 1 for hydrogen times 2 because there are 2. Then plus oxygen 16, that gives us 18. So we need to divide, so we shall actually have 3.52 divided by 44. That gives us 0.08. And we'll literally be able to have 1.40 divided by 18. That gives us, let me transfer that into decimal, so 0.077. So this is the same as 0.08 divided by 0.08. You see, that means the mole ratio of carbon dioxide to that of water, in terms of what we have as this hydrocarbon has to get burned here, is just 1:1. Then that translates into us now proceeding to getting now. Just a minute, I need to get more space for this for us to get the concept here. Just a minute. So this is what we have. I think you can now be able to see. So we'll again come here and get the mass of carbon in carbon dioxide. We are not going to use elements. We shall use carbon here and we shall use hydrogen. Why? We are burning a hydrocarbon. So we need to specifically get the exact amount of carbon and the exact amount of hydrogen in as far as this structure is concerned. So how much carbon and how much hydrogen are in carbon dioxide and water, and that might be directly equivalent to how much we have in this hydrocarbon. So we shall say carbon is 12 over the total molar mass, which is 44, then times the mass of the whole compound, 3.52 grams. So that you can be able to know the exact mass of carbon. So 12 divided by 44 times 3.52. So that gives us 0.96. So we have 0.96 grams of carbon in that carbon dioxide, having a mass of 3.52 grams. Then a mass of hydrogen in H2O. So we shall have 1, that is 2. So 1 times 2, then divided by 18, then times the whole mass 1.40. So we shall have 2 divided by 18 times 1.40. So the mass is 0.0, so we shall have 0.156 grams. Okay, so you'll come here and say element, then we have mass, then gram, of course, or molar mass, no problem. Then moles, we have moles here, then mole ratio. The same thing has to actually get applied. Talk about the compound, the mass of that compound, or the mass of those compounds, the molar mass, then the moles. How do you get the moles? Mass over molar mass. So we just took this mass divided by this molar mass to get this moles. And further divide, and you'll be able to get the mole ratio. So of course they always say that you divide with the simplest number here to get the simplest whole number ratio. But it's still 0.08, 0.0 just gives us 1:1. Okay. The element is carbon, the element is hydrogen. Mass of carbon 0.96, mass of hydrogen 0.156. Molar mass of carbon, that is 12, hydrogen 1. Then we'll proceed the moles. We shall say 0.96, that is the mass divided by the molar mass 12. It gives us 0.08. And then 0.156 divided by 1, that just gives us the same answer. 0.156 divided the smallest, 0.08. 0.08. So 1 then divided by 0.08 gives us what? 1, that is just 2. So it's 1.95. So it means 1 carbon atom in 2 hydrogen atoms. This becomes now the empirical formula of that hydrocarbon. Thank you.